Let's see. Yep, we're live.
Okay.
So yeah, for question 1, I got no, only because 2 vectors can't add up to 0 if they don't have the same magnitude.
Yeah.
Right. Yeah, that's what I got too. That they can only add up to 0 if they're the same magnitude and going opposite directions.
Yeah.
Yeah, 3 vectors of all different ones can if the 2 vectors equal the first vector or something like that, right?
Yeah, correct.
Yeah.
Okay. Should we go to question 2?
Yeah.
For question 2, I got 30.8 meters.
Yep.
Okay.
You got, what did you get?
30.8.
That's what I got.
Okay.
And then for the compass direction, I had what?
Oh, go ahead.
54.25 degrees north of west.
Yep.
And you get that by just doing the tangent, right?
Yeah. You do the inverse tangent of your angle.
Right. 25.
Yeah, so you just do the 25, well, tangent,
25
25 or 18.
Of them, just depending on which sides you use.
Yeah, it's true.
Isn't the y-axis always over the x-axis?
Yeah, but since you know all 3 sides, you can use any sine, cosine, or tangent.
Okay.
Tate just tried calling me on Hangouts. So I think he's a little confused.
Yeah.
I'll send him the invitation again. So we got 54.25 degrees, right?
Yeah.
Sweet.
Then we're on number 3, right?
Yeah.
So, are we waiting for tape, or are we good to
We'll just keep going.
So for 3, we're just trying to figure out VA and VB, right?
Yeah.
Correct. For VA, I got 3.453 meters a second.
For VA,
Yes.
I got 6.01 for VA and 3.0 for B. But I could have totally done it wrong.
For
What'd you
B,
get?
I got
What'd you get? Was it Whitney who said that?
Yeah,
Yeah. What'd you get?
I got 6.01 meters per second VA and then 3.00 meters per second for B.
So they have to add up to 6.72. So you know that.
They do, like, if you do the square root of them, right?
No, they have to add up together. The two velocities add to give you a total v total.
Okay. I don't know what I did wrong. 'Cause
How'd you
we
work
do-
that, Jake?
so for VA, I got 3.453,
Mm-hmm.
and then for VB, I got 3.943. So I guess we can just round that up to significant figures and go from there.
And how did you do it?
But that,
So first I do see.
It's like a law of sines thing.
Yeah, it was a law of science. Let's see. Let me go back over my notes.
Let me Google that.
I'm gonna say I did it with 6.72 times the cosine theta. That's wrong, obviously.
Interesting. Let's do this. Sine.
So I ended up finding like an example problem of this one because I wasn't sure.
Yeah.
And it seemed to work out pretty well. I don't know. I'm trying to see how I would describe this. So
I was just using the examples from the book. Okay.
I looked one up online.
Okay.
So
So I think I know how to do it actually.
Okay.
You use the law of sines.
mhm.
49.5. Let me just double check to make sure it's right. I know. I just broke my calculator, so everything sucks for a little bit. I have to use the Google search bar.
My son, what did you get?
So I did the V total cosine of in parentheses of 22.5 degrees plus 26.5 degrees. And then I put that equals to the VA cosine of 22.5 plus the VA cosine of the three angles. And then that equals VA sine of 49.5 over equals V total sine 23 degrees. And so then you divide V total 23 degrees over sine 49.5 degrees.
I did it a little different, but it still works out.
Okay.
So what you do is you use the law of sines, which says that sine of angle A over side A is equal to sine of angle B over side B.
Mm-hmm.
So you do sine of 23 degrees over X, because you don't know the side, VA, velocity A, equals the sine of 130.5 degrees over 6.72. Then you cross multiply and you get 3.44.
Yeah.
But to significant figures, I mean, it's just 3.4 or 3.5. Does that make sense? Does that make sense?
Yeah, that does. Mm-hmm.
I was gonna say kind of. I'm still lost.
Have you used the law of sines before?
No.
So basically, it has this triangle, and each angle is labeled the same letter as the opposite side.
Okay.
So like that. Dang, I'm not sure if it's going to be visible. Can you see that triangle?
Yeah.
And then the law of sines says that the sine, here, I'll just bring it up on my computer and then share the screen. How do you do that again? There you go. Okay. Can you see this?
Yeah.
So the law of sines just says if you take the sine of the angle over this side, it's the equal to the sine of a different angle over its side.
Okay.
So then to solve for it, all you have to do, since you know one of the sides and one of the angles of that, the angle of that side, you can just find it by plugging it into that formula.
Okay.
Hopefully that helps a little bit.
Yeah.
So for this problem, it would be the sine of angle A, which is 23 degrees, and that's given to us in the problem, over side B, or over side A, which is, we don't know, right, is equal to the sine of the other angle, 130.5, which is opposite the side that we do know, which is V total, which is 6.72 meters per second.
Okay.
And then to find the other side, you can just subtract 3.45 from 6.72.
Sweet, that was helpful. That was a little easier the way I did it. So
I get a slightly different answer for VB, though.
Be 3.28 or something like that.
Yeah, that's VB. It's been a little while since I was in trig, though, so
Yeah, it's been like 10 years since I was in trig, so that's.
yeah, I don't blame anyone for forgetting it either. Is that all that one asks?
Yeah, that one just asked for the magnitude of velocities.
Can we move on to 4 then?
yeah, we should be good.
Sweet. Suppose you add 2 vectors, A and B. What relative direction between them produces the resultant with the greatest magnitude? Ooh, I don't know.
you add two vectors A and B. Yeah, this one I struggle because I was
Magnitude doesn't include direction, does it?
No.
Well, if they're laid on top of each other, then they'd have the greatest magnitude together, right? Because they wouldn't be subtracting from each other. Whereas if you put them at any angle, you get less than the addition of the both of them, right? So if you put them at opposite angles or 180 degrees apart, that would probably be the least.
Yeah, no, that makes sense.
Mhm.
So when would it be the minimum, the smallest magnitude?
When
Whereas-
when they're 180 degrees separated.
Okay.
And then could it be the smallest if you have it like laying on top of each other?
That's
Like-
the largest. If you think of each vector as someone who's pulling in one direction, they're going to pull the most when they're pulling in exactly the same direction and the least when they're pulling in opposite directions.
Oh, okay, that makes sense.
So like when the velocity and acceleration are going in the same direction is when it's the fastest, and it slows down when they're going in opposite directions, right?
Yeah, sure. Or if two velocities are pulling in the same direction, the opposite directions, yeah. So it's good to think of like trucks pulling against each other.
Yeah.
Yeah, that makes sense. Let's do that. Sweet.
Yes.
Cool.
So that's it for number 4, right?
Yep.
For number 5, I got 120.4 meters for the C. Like the length of side C.
Mm.
And how did you get that?
Using the rule of cosines. I don't know. That's right.
The law of cosines.
Uh-huh.
Let's find that one.
Cosines.
Where C squared equals A squared plus B squared minus 2AB cosine of C.
Right.
Yeah. How'd you find angle C?
I got 80 degrees just by finding the angles of the little triangle, like on the bottom. Can you guys see me?
Yeah.
Okay, I can show you on my paper. Maybe you can see it.
Oh, yeah. I
I
guess.
don't think you can read it. Never mind. But pretty much that like little triangle on the bottom.
Mhm.
If you have like 21 degrees, and then you have a right angle, with like that 11 degrees there.
Mm-hmm.
So you can just subtract one from 180, the 21 degrees plus the 90 degrees.
Oh, you can find the third angle.
Yeah.
makes But then how do you, so you find the angle in between A and B. That makes sense. How do you find the angle in between A and C?
That was from the law of cosines, like after finding the bottom angle.
Oh, you only need one angle, but right?
Do you?
Yeah,
I
you
don't
only
know.
need one angle, but you need angle C.
Hmm.
I guess it doesn't really matter.
So actually, I just realized that bottom angle isn't 80 degrees, 69.
Yeah, the bottom angle is 69, but what's the top angle?
Didn't do that right.
Oh, no, that's right. You're right. I'm sorry. I was messed up.
Yeah.
Yep, that makes sense. And what was the answer?
I got it wrong, but I got 120.4
Why'd you get it wrong?
because I used 80 degrees instead of 69.
Dang it.
So I have to go through that again.
So, okay.
Okay, so for the length of side C, I got 115.2 meters.
I got 106.8. Did you use 80 for A?
I used 69.
For A?
Uh-huh.
So 80 is side A, right?
Yeah.
Oh, that's right.
So I did 80 squared plus 105 squared, which is side B, minus 2 times 80 times 105 cosine of 69 degrees, and then square rooted it.
Okay, that's right.
And is it just asking for side C?
It's also asking for the angle.
Which angle?
The one, like on the top left of the picture.
So, oh yeah,
Mm-hmm.
that shouldn't be too hard. We can use the law of sines again.
Yeah, it just says she incorrectly calculates the length and orientation of the third side C. What is her result?
Sine of 69 degrees.
The length and orientation.
Okay. For the angle, I got 46. Whatever 90 minus 44 is, right? 45.65.
That's what I got.
Hey, so I found actually the same problem online.
What?
They got 92.3 meters for. Can you hear me?
Yeah.
So I found a similar problem. Well, same problem.
Yeah, I
They
can't
got
hear you anymore.
92.3 meters. How about? Can you hear me now, Zach?
You're just like really garbled once you start talking.
Anything?
I can hear you better now.
Yeah, it's a little better. Now it says he's muted. So how did you find the degrees? Zach.
Oh, I used the law of sines. So I put it sine of 69 degrees over 106.8 equals sine of x over 80.
Sine of 69 over.
Sine of 69 degrees over 106.8.
Right. Okay, so just like, okay. Okay. So 106.8 meters is 35.65 degrees.
Well, Jake's saying that our side C might be wrong.
Oh, okay.
Yeah. So can you hear me now, Zach?
Yeah.
Yeah.
So I found this problem online, and they got 92.3 meters for size C. And for the angle, they got 53.7 degrees.
Well, if they got a different,
They broke it all down.
did get a separate angle.
I can.
No, you're right. Keep showing me.
So I'll. What they did the A plus B plus C equals 0.
Right.
Oh, that's smart.
Yeah, and then they did sine 11 degrees for B and A cosine 21. And then from there, you just plug in CX equals negative A minus B X. And so then you plug in your cosine and sine, and then plug in your 80 meters for side A for side B. That gives you negative 54.65 meters for CX. And then for CY, you do negative AY minus AB. So you do the A cosine 21 minus B cosine 101.
So they just separated the vector into XY components and then solved for each one.
Yeah, and I remember watching a video on Khan Academy, and that's what they did on multiple vectors. They broke each vector, and they broke down both vectors into individual vectors.
I mean, it's definitely smart. I think our assumption that the dotted line makes a right angle might be a problem.
That might be why. I don't know. I mean, I don't know why it makes sense. I don't know why it didn't come out the same, because I figured it would.
Yeah. Can you just do something for me? Can you just take a screenshot of that and then screen share it with us? Like the part where they find all the angles?
This
Yeah,
part.
that part.
Okay, yeah. Is that what?
Yeah, that's perfect.
Okay, I'll screenshot that, because that makes a lot more sense breaking it down to. Okay.
Hey, Jake,
Yeah.
why don't you just send me the link?
Did you get it on your email, Zachary?
What?
He
I
sent
sent
the
you-
screenshots to the email,
Yeah.
Oh, sweet.
so I pulled them up.
Did you get it, Zach?
I did. Yeah.
Okay.
Okay, I rewrote the equation. So why do we assume that a plus b equals plus c equals 0?
That's one of the equations I believe was in the book as well.
Yeah, it said it in the book, and it's on the diagram for the question.
I just don't know why.
Yeah.
Yeah, I mean, they gave us the a plus b plus c equals 0 in the equation and 5 in the question, I mean.
Right.
So,
I'm trying to find the book because I remember seeing it.
because I know for the next question, for question 6, I did r equals a plus b. I did pretty much the same thing.
I think it equals 0 because it's going back to where it started.
Mm,
So kind of the answer that we gave on number 4,
right.
going back to the beginning.
And then for like question 6, they gave us the equation for that one as well. They do like a plus b equals r. And so you can do, yeah, I guess I can explain that one later. I don't know if I got that one right though.
Why? Do we know why it's one side times cosine of 21 degrees and the other side by sine of 11?
So I'm not sure why one side is cosine and why one side is sine. I mean, there has to be a theory or a law for it. For why we do that.
Might just be a trig identity that they're using though. Remember those?
I don't. It's been forever since I've taken trig, so I'm like halfway lost in this class.
It's been like 4 years.
It's like,
So I'll look into that, but for now, keep going. You get equals 54.65 meters, and then this is the easy part. Oh, did someone just disconnect?
I think Whitney did.
There's a bunch of ways to find the angle once you know this side.
Hello?
Like this makes sense.
Did anyone else say? Okay. What happened?
Here, I'm gonna send you another.
Where did they get 101 from?
For what question?
So CY equals, and the E cosine times 101 degrees.
Yeah, no, that's my only dilemma. I don't know how they got 101. Let's see. So I sent you another email with the picture screenshot.
Yeah.
Is this still for question 5?
Yeah.
Yeah.
Okay.
Just don't get where they got 101. Maybe they're where they got 101. Maybe they just made it. Mistake. Yeah, they did. Typing mistake.
All right.
Are you still working through number 5?
Are you working through number
I just finished.
5?
Okay.
We're still working on number 5, right?
I think we just finished 5. We're starting 6.
So what did we finish with on 5? It keeps cutting out.
As long as you who's Echo?
I don't know who's echoing.
If you just want to all mute until you start talking.
I hear an echo from
I
everyone.
hear an echo from everyone.
Yeah, that's because we're here. So if we all just mute until you start talking, there won't be a problem. I wonder if there's still one. Can you guys hear me?
Mm-hmm.
Sweet. Okay, so once you figure out, did you see the picture? If you saw the picture that he sent everyone, it kind of explains what they did. So for some reason, there's a rule that you can divide the x and y components of a line into that side times the cosine of the angle, and then the y component into that side times the sine of the angle. And that's just apparently true. So once you establish that, you can just plug the numbers in. And you're just trying to subtract, or really, I guess, add. You're just trying to plug it into the original equation, c equals negative a minus b, using the components that you found. And that kind of explains it in the screenshots.
Hey guys, I have to get off soon. But if you guys have any questions, because I didn't do 6, couldn't figure that one out all the way. But I did do 7 through 10. And so if you want, I can send you a picture of it tomorrow of mine. And
That'd be great.
you guys can, if you guys do something different, you guys can compare or whatever before we submit the final group. Is that cool?
Yeah, it's good.
Sweet. Hey, thanks, guys. So I might contact you with some questions in the lab.
Perfect.
Hopefully. So
Too bad we couldn't get Tate involved. Okay, let's just It doesn't look like we're close to finishing it as a. I actually also have an appointment to be getting to, but how do you want to finish this up?
I already did number 6. I don't know if I did it right.
Okay.
Okay, I did it too, but again, I'm not sure if I did it right either.
Do you want me just to let you know what I got?
Yeah.
Okay,
So for R, I got 64.7847 kilometers.
and
And then I got 40.8864 degrees northeast.
Okay. That wasn't even close to what I got.
Not close?
No, so that's what I was gonna ask. So do you use the Pythagorean theorem for this one, or what law did you use for this one?
Yeah, I used the Pythagorean theorem to find R, and then I used cosines
Okay,
to
so
find the angle.
I got
So wait.
50
You use
kilometers.
the Pythagorean theorem?
Yeah, I did.
Oh, that's just the right triangle, right?
Yeah, it's only for right triangle.
That's why.
That's right. Okay.
Okay.
So then, since it's not a right triangle, what law do we use?
So it looks like it wants us to divide them into vectors again, x and y. And the rule is a plus r. Which doesn't make sense. Okay, I have to go by 9:30, but I doubt we'll do the next 5 in 15 minutes. So how can we finish it out? Like, do we want to meet on a different day, or what are we thinking?
We could just finish it up ourselves and then send each other like pictures of what we got
Let's do
and
that.
then just like compare. That might be really easy.
When is this due?
It's due Thursday night. So we have to have everything submitted Thursday night by, I think, 11 o'clock your guys' time.
In the lab is due tomorrow.
Yeah, the lab and everything's due tomorrow.
Sweet.
And then we have our exam this week, too. So
Well, I'm glad they say our material right before the test. Okay, yeah.
So we just want to finish up and then send pictures of what we got.
Yeah, so once I finish, I'll just take pictures and send them to you before I submit it. And then we'll just get anything. We'll just let each other know.
Yeah, because on the instructions it said we can, in the report you can use pictures as well.
Right.
So,
Perfect. Do that then.
and then this way you can include Tate as well.
Mm.
Send his pictures. His
Great.
work.
Okay. Well, just message me an email on my end by like Thursday morning so that we can submit it on time.
Okay.
Okay, we'll do that.
Sounds good.
Talk to you guys later.
Okay.
Bye.